Okay, this question, really the first hurdle is to spot which S1 topic it's on. And I'd strongly urge you to pause the video right now and just read the question and just decide in your own mind what topic you think it is, bearing in mind what's already happened on the paper. Pause the video and make a bit of a guess now. Okay, well, I assume you've done that and made your decision. It mentions probability. However, we've already had one major probability question, so the other thing to bear in mind is maybe it's the binomial distribution question, for which you have to say, are we counting the number of successes in n independent trials? And if you look at what's happening, he's having 15 goes, and we're counting his number of hits. So we're counting the number of hits in 15 independent, there we go, goes at hitting the target. So there's our counting successes in n independent trials. So it's a binomial question. We're going to be setting up x with a binomial distribution. We're going to be deciding a value of n, which I think we've already hinted at, and a value of p, which is the probability of success on any trial. Check your p-value is a nice one. 0.45. Is that in the binomial tables or not? If 0.45 isn't, but 0.55 is, then you'd be better off, instead of counting the number of hits, counting the number of misses, because that will enable you to use the binomial table, but you will have to re-express all these probabilities that you're calculating by thinking about the number of misses involved. All of these involve ranges of several values of x, so the way to calculate those that they normally put first is to use the binomial tables from your formula book, decide the range of x values. I strongly recommend, for the first one for example, writing out all the possible outcomes from a binomial, putting dots in the bits that are a little bit boring, but all the values from 0 to 15 we need to show on a diagram what corresponds to at most 5, draw a loop around the probabilities we want, so we're absolutely sure that we're looking at the right number in the table. Is it 5, is it 4, or is it 6? If you've decided exactly which of these values, then you shouldn't go wrong with that. And you've got 4 of those, including a last one where you have to be between two values, where it's particularly important to really set up a diagram that shows you which numbers to look up in the table. And that's part A, and this really should be, 8 of the easiest marks on the paper, just routine use of a binomial distribution. Then part B just goes off in a slightly different direction for a little bit. Okay, lots of reading to do, but basically we've got someone who has 2 goes. She doesn't bother with the second go if she hits with the first, but we've got the chance of hitting with the first barrel, and then we've got the follow-up chance, if she misses with that one, of hitting with the second barrel, and we want her probability of hitting a target to be 0.97. This isn't binomial, this is considering cases really. The first case is she hits it straight away, the second case if she misses and then she hits. So you need to work out a simple probability plus a combined probability. You can draw a tree diagram to help visualize that, but we need to find 2 probabilities, one itself a calculated one, that add up to 0.97 for 2 marks. However, if you find that difficult, don't despair, there is a re-entry point. This is a show that question, that 0.97 is the value we need to carry on. Because what's happening in the next one is that she's having 50 goes, again with her 2 barrels, and she's got to hit at least 48 out of 50. And we know the probability she hits any particular target is 0.97. So we're now counting the number of hits out of 50 goes, so it's another binomial. This time the p-value 0.97 definitely isn't in the table, so you've got a choice here. You can either do what I mentioned earlier and count the number of misses instead of the number of hits, and re-express this idea of hitting at least 48 in terms of misses, and then you can use the tables. Or the other thing that you sometimes do with a non-tabulated p-value is you forget about the tables and you use the formula instead. Now that's normally most useful for a one-off value, but here at least 48 out of 50 breaks down into only a few cases. It's 48 or 49 or 50, so you can use the formula 3 times and add up 3 answers if you prefer, but it is possible to use the tables by looking at the number of misses, not the number of hits. And then finally in part 3 we've got to calculate, we've changed the number of targets, so now we've got 80 targets instead of 50. We've still got the same probability, so we've still got values of n and p, and we want the mean, and just the mean. You could have asked for the variance or standard deviation as well. We want the mean of a binomial distribution. There's a formula for mean and variance of the binomial distribution on page 11, which is actually where that formula for calculating binomial probabilities lives as well.